The dry air of western Texas, thick with the scent of creosote and dust, hung heavy and still. Then, without ceremony, the earth itself began to scream. A deep, guttural groan, felt more than heard, shuddered through the bedrock far beneath the sun-baked plains north of Midland. It wasn't the sharp jolt Californians might recognize. This was a visceral, rolling tremor, a beast stirring from slumber deep within the planet's crust. Reports flooded the United States Geological Survey, USGS, within minutes. Not just tremors, but a chilling chorus of, "The ground is moving. Something's tearing apart," flooding in from Odessa, Andrews, and the Austin metro area, hundreds of miles away. This wasn't distant machinery. This was the planet fracturing. And then, the land split. Long, jagged wounds, raw and violent, ripped through the parched earth near the communities of Wink and Kermit, places already scarred by geological unease. These weren't mere cracks. They were canyons in miniature, hundreds of feet long, yawning open with terrifying speed, swallowing fence posts, buckling asphalt roads like discarded cardboard, and leaving the land scarred with sudden, precipitous drops of several feet. The scale was unprecedented, the violence shocking. In response, the USGS did something almost unthinkable for the stable heartland. They issued a rare, dire red alert. This wasn't a caution. It was a siren blast reserved for volcanic eruptions or catastrophic, imminent seismic events. Its deployment in central Texas was a seismic shockwave in itself, a stark, terrifying admission that the very foundation of the region, its infrastructure, its communities, and its stability faced an extreme, escalating geological hazard. The implications were profound, immediate, and chillingly uncertain. The prelude had been deceptively mundane. Minor shudders dismissed as heavy trucks thundering down remote highways or the distant, rhythmic thump of drilling rigs. The background noise of the Permian Basin. But these subtle tremors were the earth-whispering warnings in a language few understood. Within hours, the whispers became shouts. The tremors intensified, evolving into a series of sharp, violent jolts. Not isolated events, but a cascading sequence of subterranean shifts, like dominoes falling in the dark. And then came the rupture. Eyewitnesses, frozen in disbelief, described the surreal horror, the ground before them simply parting, tearing itself asunder with a sound that defied easy description, a chilling fusion of subterranean thunder, the splintering groan of immense rock strata failing, and the visceral rip of roots and soil surrendering. Roads, lifelines through the vastness, snapped like brittle twigs. Established fence lines sagged into newly formed voids. In some places, the land dropped away sharply, creating sudden cliffs where flat earth had been moments before. While such apocalyptic scenery might be expected along the infamous San Andreas Fault, its appearance here, in geologically tame Texas, sent urgent, terrifying questions ricocheting through the scientific community and the terrified populace. What monstrous force was unzipping the bedrock? And where, horrifyingly, would it stop? The epicenter of this unfolding cataclysm lies deep within the Permian Basin, a sprawling subterranean kingdom saturated with the fossilized remains of ancient life, now the lifeblood of modern industry. For decades, this region has been the engine of American energy dominance, subjected to relentless industrial-scale extraction. Billions of barrels of oil and trillions of cubic feet of gas sucked from its depths. The methods are brutal on a planetary scale: deep well injection, hydraulic fracturing, fracking, the shattering of shale with high-pressure fluids, and the forced re-injection of vast quantities of toxic wastewater back into the Earth's bowels, a desperate attempt to hide the waste product of our thirst. This industrial onslaught hasn't just extracted resources, it has fundamentally reshaped the subterranean architecture. Geologists have long debated the causal links, the delicate dance between human activity and induced geological instability. Theories about sinkholes from collapsing cavities left behind by extracted oil and gas, or induced seismicity, human-caused earthquakes, triggered by the lubricating pressure of wastewater injection, were part of the academic discourse. But the sheer brutal scale and terrifying velocity of the fissures now scarring the surface have transcended debate and plunged the scientific community into stunned reckoning. This wasn't a localized sinkhole. This was the landscape itself undergoing systemic failure. The data, the raw visual evidence of the Earth tearing open, presented a scenario far more extreme, far more violently dynamic than even the most cautious models had dared to predict. Seasoned geologists, accustomed to the slow grind of tectonic plates, found themselves confronting a crisis unfolding with alarming, real-time ferocity. While the USGS meticulously analyzes the precise trigger sequence, preliminary assessments paint a horrifying picture of synergy between ancient forces and modern intervention. Natural tectonic stress, accumulating with glacial slowness over millennia deep within the crust beneath West Texas, had reached a critical threshold. This relentless background pressure, the Earth's own slow-motion agony, provided the potential energy. Layered catastrophically upon this were the countless wounds inflicted by industry. The boreholes piercing the strata like needles, the violent pressure fluctuations from injection and extraction, the cavernous voids left where hydrocarbons once resided. These anthropogenic stresses acted like a corrosive acid, relentlessly weakening the rock fabric, compromising its structural integrity. The equilibrium that had held for ages was shattered. The ground, overloaded, fractured, and drained of its natural support, could no longer bear the burden. It simply gave way. What transforms this geological event into a genuine nightmare is its terrifying unpredictability. These fissures aren't appearing along known, mapped fault lines where monitoring might offer some warning. They are erupting violently in locations that showed zero prior indications of instability, emerging like malignant growths from seemingly stable ground. The profound fear gripping scientists and emergency managers isn't just that more fissures will appear, but that these surface ruptures are merely the visible symptoms of a far deeper, more extensive network of subterranean collapses. Could these interconnected failures cascade into a regional subsidence event, a large-scale sinking of the land? Or worse, could the accumulating stress find release in a powerful, induced earthquake ripping through the weakened crust? The ground isn't just cracking, it's becoming a treacherous, unpredictable minefield. The infrastructure woven across the Permian Basin, the intricate web supporting the national energy supply, now hangs by a thread over this widening abyss, a dense labyrinth of high-pressure oil and gas pipelines, well pads bristling with machinery, processing facilities humming with volatile hydrocarbons, and the skeletal grids of electrical transmission lines. All are perched precariously above ground, undergoing violent metamorphosis. Roads and bridges, engineered for predictable loads, not for the earth liquefying beneath them, are already exhibiting grotesque deformities. Asphalt buckling into tortured waves, bridge abutments showing hairline fractures that speak of profound structural distress. The damage is leaching into the fabric of communities. Foundations of homes and businesses in Reeves, Loving, and Winkler counties are cracking with ominous speed, rendering structures unsafe, displacing families, and strangling local commerce. Emergency management teams, working in frantic concert with USGS geologists, are deploying every tool at their disposal. Ground-penetrating radars scanning the shallow subsurface, satellites high above capturing millimeter-scale ground deformation through interferometric synthetic aperture radar, INSAR, dense networks of seismic monitors listening for the slightest subterranean whisper of further movement. Yet there's a palpable, chilling sense that the Earth itself is moving faster than the technology designed to understand it. The data streams in, complex and often ambiguous, while the ground continues its relentless, destructive shift. The race is not merely to comprehend, it's a desperate bid to anticipate the next rupture before it claims lives and critical infrastructure. The reverberations of the Red Alert extend far beyond the immediate visceral terror of splitting Earth in West Texas. This unprecedented designation automatically catapults the crisis onto the national stage, triggering the mobilization of federal agencies, FEMA, the Department of Energy, the EPA, and activating complex protocols for potential large-scale disaster management. It forces an uncomfortable, urgent question upon the nation. If this can happen in Texas, long perceived outside specific karst regions as geologically stable, what about Oklahoma, where induced seismicity has already rewritten risk maps? What about the oil fields of New Mexico or the fracking zones of Colorado and North Dakota? The Texas event acts as a horrifying case study, a flashing red warning light demanding a comprehensive, nationwide reassessment of subterranean stability in every region subjected to intensive hydrocarbon extraction. The assumption of geological benignity in the American heartland has been shattered as completely as the ground near Kermit. Policymakers, regulators, and energy companies nationwide are now compelled to confront the terrifying possibility that the very act of extraction, on the scale demanded by modern economies, carries an inherent, potentially catastrophic geological cost that previous risk assessments may have dangerously underestimated. The Permian Basin's agony is forcing a fundamental reevaluation of the ground beneath our feet, wherever industry drills deep. The environmental consequences unfolding alongside the physical destruction promise a compounding, long-term ecological disaster. As the Earth's skin tears open, it exposes strata buried for eons, layers of soil, rock, and sediment long isolated from the surface environment. This geological vivisection creates new pathways, chimneys for the release of trapped subterranean gases. Methane, a potent greenhouse gas with over 80 times the warming power of CO2 over 20 years, along with carbon dioxide, hydrogen sulfide, and potentially radon, can now seep uncontrolled to the surface, poisoning the air and contributing to climate change in a vicious, unplanned feedback loop. Perhaps even more insidious is the threat to the region's fragile water resources. The fracturing of underground aquifers, vital ancient reservoirs of fresh water, is a nightmare scenario. These newly created fissures could allow the migration of brines, hydrocarbons, heavy metals leached from disturbed strata, and contaminants from surface activities like spilled drilling fluids or chemicals stored near well pads directly into drinking water sources. Early alarming signs are already manifesting. Rural water wells within the affected zone are reporting sudden, unexplained turbidity, cloudiness indicating suspended particles, and spikes in mineral concentrations like chloride, sulfate, and total dissolved solids. Water boards are scrambling, conducting emergency sampling, but the fear is pervasive. Has the contamination already begun? Will clear water become a memory? The ecological disruption extends to the land's inhabitants. Wildlife, reliant on stable landscapes for migration corridors, nesting, and foraging, finds its world violently rearranged. Vegetation patterns, finely tuned to specific soil gradients and moisture levels, are torn asunder, buried under debris or left clinging to the edges of newly formed cliffs. Topography shifts of even a few centimeters can alter drainage patterns, microclimates, and soil chemistry, triggering cascading effects through ecosystems. Effects that biologists fear may take years, even decades, to fully manifest and understand. With the ground still actively shifting, ecologists can only observe, document, and dread the unknown breadth and duration of the damage. The land is not just breaking, its very ecological memory is being erased. Beyond the measurable physical and environmental damage lies a profound corrosive psychological toll eroding the spirit of West Texas communities. Residents of towns scattered across the Permian, places like Monahans, Pecos, Natrez, have lived for generations alongside the rhythmic clang of drilling rigs, the rumble of tanker trucks, the occasional minor tremor shrugged off as the cost of doing business. They are a resilient people, forged by harsh landscapes and boom-bust cycles. But this is existential. The visceral horror of witnessing the ground beneath your feet, your home, your child's school, literally tear itself apart transcends industrial nuisance. It strikes at the core sense of security, the fundamental belief in the solidity of the world. The sound, the sight, the sheer unnaturalness of it rattles even the most stoic rancher. Fear is manifesting in tangible ways. Schools in several districts have preemptively closed, not for weather or pandemic, but because parents refuse to risk their children traveling roads that might vanish beneath the bus. Families, Generations deep in the region are packing essentials, making agonizing decisions to leave homes and livelihoods behind, haunted by the terrifying uncertainty. Will the next fissure open in their backyard? Community gatherings are thick with anxious whispers, rumors spreading faster than verified information. The uncertainty breeds not just fear, but anger, distrust, and a pervasive sense of helplessness. The land, their anchor, has become the agent of their potential destruction. This seismic shift in reality extends brutally into the realm of finance and liability, plunging homeowners and businesses into a Kafkaesque nightmare. Standard property insurance policies often contain sweeping exclusions for damage caused by earth movement, a catch-all term encompassing earthquakes, landslides, and sinkholes. The catastrophic fissures ripping through West Texas, however, exist in a terrifying legal and actuarial gray zone. Is this a purely natural disaster? Or is it induced, demonstrably exacerbated, perhaps even caused by specific industrial activities? This ambiguity creates a quagmire for insurers and policyholders alike. Insurance companies face a surge of claims for cracked foundations, buckled driveways, collapsed water wells, and structural damage. But the cause is contested. Investigations are underway, spearheaded by state agencies and plaintiff attorneys, probing injection records, extraction volumes near fracture zones, and the geological mechanics of failure. If a direct causal link is established between specific wastewater injection practices, aggressive fracking operations, or decades of resource removal in these surface ruptures, the legal and financial repercussions could be tectonic. Class action lawsuits targeting operators could dwarf previous environmental settlements. Municipalities facing crippling infrastructure repair costs would seek restitution. The potential liability is staggering, threatening not just company profits, but their very existence. For individual homeowners, however, the immediate reality is a purgatory of bureaucratic paralysis. Claims are denied or suspended pending investigation. Repair estimates are impossible as the ground remains unstable. Property values plummet towards zero. Families face the agonizing choice: pour dwindling savings into patching a foundation above shifting ground, or abandon their largest investment, potentially left with mortgage debt on worthless land. The financial ground is collapsing as surely as the physical terrain. What elevates the USGS Red Alert from a regional emergency to a potential national catastrophe is not merely the terrifying damage already inflicted, but the horrifying specter of what might still be to come. The surface fissures, dramatic and destructive as they are merely the visible expression of a far more profound, deep-seated pathology. Instability is festering within layers of rock and sediment across potentially hundreds of square miles. Advanced seismic modeling, analyzing the accumulating data from newly deployed sensor arrays, reveals disturbing patterns. In certain zones, tectonic and anthropogenic stress is building faster than it can dissipate through minor tremors or slow deformation. The terrifying possibility on every geologist's mind is a significant induced earthquake, potentially registering between magnitude 5.0 and 6.0. Such an event occurring within the weakened, fractured crust of the Permian Basin would not be a mere shake. It would be a detonation. It could violently widen existing fissures, trigger thousands of new ones, cause critical high-pressure pipelines to rupture catastrophically, unleashing geysers of oil or gas primed to ignite, collapse chemical storage tanks releasing toxic clouds, or induce widespread sudden subsidence in areas currently deemed stable. The nightmare scenario is a cascading failure, a pipeline rupture igniting a firestorm near a chemical tank farm, triggering secondary explosions, while simultaneously severing transportation routes needed for emergency response, all while new ground failures isolate communities. It's this potential for domino effect disaster that keeps emergency managers awake and justifies the stark, unprecedented red alert. In response to this escalating crisis, the geological community is converging on West Texas with a sense of profound urgency and grim fascination. Geologists, seismologists, and geophysicists from universities, government labs, and private consultancies are deploying a formidable arsenal of technology. Dense networks of portable seismographs, more sensitive than the region's sparse permanent stations, blanket the area, listening intently for the faintest precursors to larger movement. Drones equipped with LiDAR and high-resolution cameras map the fissures in exquisite, horrifying detail, creating 3D models to track their growth and interaction. Satellites overhead, utilizing advanced INSAR techniques, measure ground deformation down to the millimeter, revealing subtle subsidence bowls and stress patterns invisible to the naked eye. Magnetotelluric surveys probe deep electrical conductivity to map subsurface fluid pathways and potential voids. Teams are even conducting rapid targeted deep core drilling to extract rock samples, analyzing their mechanical properties and stress history. This unprecedented data fusion aims to build a real-time, four-dimensional map of the evolving disaster, understanding the fault dynamics, fluid pressures, and stress fields driving the destruction. Yet despite this technological tour de force, a profound, humbling limitation persists. Scientists can identify zones of high stress, model probable fraction paths, and assess escalating risk. But predicting the exact location or moment of the next major rupture, the next violent tear in the Earth's fabric, remains frustratingly, terrifyingly elusive. The Earth, even under the most intense scrutiny, retains an element of chaotic unpredictability. The data illuminates the danger, but cannot always pinpoint its next strike. Amidst the frantic monitoring and damage control, a complex, contentious conversation is emerging about long-term solutions. Solutions that are fraught with economic pain, technical uncertainty, and political friction. Some environmental advocates and concerned scientists call for an immediate, dramatic reduction in drilling activity and wastewater injection across the most vulnerable zones, potentially even a full moratorium, to halt the anthropogenic pressure destabilizing the crust. Let the Earth rest, they argue. Allow natural pressures to re-equilibrate before further strain triggers irreversible collapse. The energy industry counters with economic doomsday scenarios. Such measures would cripple the national energy supply chain, devastate local economies built entirely on extraction, and cost tens of thousands of jobs overnight. They point to technological fixes, enhanced subsurface monitoring networks tied to automatic injection shutoff valves, refined models to avoid drilling near critically stressed faults, or even experimental geoengineering techniques like injecting specialized grouts or polymers into voids to provide artificial support. Engineers propose sweeping infrastructure reinforcement, retrofitting pipelines with flexible joints capable of withstanding significant ground movement, designing new well pads and facilities on floating foundations or deep pilings anchored in stable bedrock far below the disturbed layers, implementing radically new building codes mandating earthquake-resilient designs even in regions previously considered low risk. But all these solutions, restraint, technological mitigation, or massive infrastructure overhaul, demand immense resources, billions of dollars, years of research and development, complex regulatory overhauls, and a level of political consensus currently absent in the polarized landscape of energy politics. Meanwhile, the land offers no reprieve. It continues its agonizing shift, groan, and fracture beneath the weight of its own induced instability. A relentless countdown demanding answers society seems unprepared to deliver. The red alert flashing over Texas transcends a local disaster. It signals a potential turning point in our relationship with the planet's depths. For decades, the dominant narrative surrounding oil and gas extraction focused laser-like on output metrics: barrels per day, jobs created, energy independence secured, geopolitical leverage gained. Environmental concerns, when acknowledged, centered on surface pollution, greenhouse gas emissions, and habitat fragmentation. The deep subsurface, the very architecture of the crust, was treated as a passive, infinitely resilient container. A realm to be punctured, drained, and filled with waste, its stability assumed. The violent fissures, tearing through the Permian Basin, shatter that illusion with brutal force. This is the Earth pushing back not metaphorically, but physically, dynamically. It's a visceral, undeniable demonstration that industrial activity on this scale doesn't merely pollute the surface. It can fundamentally destabilize the geological foundation upon which all surface activity, cities, farms, pipelines, lives, depends. When the ground splits open, swallowing roads and shattering homes, it forces a raw confrontation with profound truths about planetary limits, the hubris of assuming control over deep-time forces, and the precariousness of modern civilization perched atop an ancient, complex, and now angrily restless geology. The Permian's agony is a stark lesson written in the language of fractured rock. The Earth is not merely a resource, it is an active dynamic system, and we disturb its equilibrium at our peril. The phenomenon of the Earth opening up is tragically not unknown in Texas, particularly around Wink and Kermit. Decades of salt dissolution, mining solution, mining for hydrocarbons and minerals, coupled with conventional oil extraction, have spawned notorious sinkholes like the massive Wink sinks, gaping maws that swallowed significant tracts of land. Stark warnings largely compartmentalized as localized anomalies. But the current catastrophe is fundamentally different, more insidious, more systematic. These are not isolated bowl-shaped collapses. They are sprawling, interconnected networks of fractures, jagged linear ruptures propagating across the landscape like a spreading spiderweb under tension. They branch, intersect, and lengthen, suggesting a profound regional-scale breakdown of the subsurface integrity. To the geologists mapping their relentless advance, the sensation isn't of a few local failures. It's of a vast subterranean support structure fracturing, its load-bearing capacity failing catastrophically across a wide front. The scale evokes chilling parallels to other geological nightmares. The terrifying sinkhole in Bayou Corn, Louisiana, where in 2012, an entire community was evacuated after the catastrophic collapse of a subterranean salt dome cavern used for hydrocarbon storage, swallowing acres of swamp and leaving a lake of briny water. Or the ominous seismic potential of the New Madrid zone in the central U.S., capable of unleashing massive earthquakes like those of 1811 to 1812 that rang church bells in Boston and temporarily reversed the Mississippi River's flow. These historical events stand as grim monuments to the latent power beneath our feet. The USGS Red Alert is a klaxon sounding for Texas, a brutal reminder that the illusion of stability is just that, an illusion. The ground we build upon, drive upon, and trust implicitly is capable of radical, violent transformation. Texas, the iconic symbol of rugged independence and unyielding strength, faces a crisis where its traditional tools, industrial might and technological ingenuity, may be powerless against the fundamental rebuke of the planet itself. As the fissures widen, snaking further across the basin, and new data streams in, painting an increasingly complex and alarming picture, the nation watches with a mixture of dread and morbid fascination. We hope the worst tremors have passed, that the cracks will stabilize, but we are forced to prepare for the horrifying possibility that the ground beneath West Texas is only just beginning its violent recalibration. The Earth is speaking in shudders and tears, and its message is terrifyingly clear.